Thanks a lot for the nice introduction, and I'm very happy to be here. You have already heard a lot of interesting insights and tips in the previous talk, so let's see if I can add a few on top of that. So, as already been said, my work is in medical imaging AI, and let's talk about how I got there. So, I wanted to start here in 2011 when I finished school, and I faced the situation. Okay, what now? I wanted to study something, but I was not sure what exactly. So I was very interested in general sciences. So I like math. I also like biology, chemistry. I like medicine. So I was really struggling finding out the right path for me. And I digged a little bit around and found this university course here called Mathematics in Medicine and Life Science, both bachelor and master courses, which I thought, okay, that sounds pretty good because it combines basically everything, focus on mathematics with a little bit of medicine and all the other life sciences. So I decided to go in there. The one thing that I didn't know at that point was that there's a lot of computer science involved, where at that point I didn't really know much about. So I thought, okay, come on, this bit of programming I will manage. In the end, I focused a lot on computer science. So that's also perhaps a tip at the beginning. Don't be discouraged if you don't know anything from the start. So I have started with the bachelor. I did the master program as well, where I also specialized in image processing, specifically medical image processing. Yeah, and I just went through that. I wrote my thesis, both bachelor and master thesis, at the same university. So while my bachelor thesis was more about modeling in neuroscience, my master thesis was more in really image processing, similar to what I do now. Although I think that the graph cut methods that I did, no one is talking about anymore. So I finished in 2016, and then again there came the question, what should I do next? So perhaps I should say that at this point, when I finished my studies, deep learning was a thing, but not that much, and it was not that much integrated into my studies at that point. So I learned about traditional machine learning methods. I had a little bit of deep learning, but not really that much in detail. So when I stopped my studies, I thought about I really would like to continue where I stopped. So I would really like to focus on medical image processing in a sense, because if you finish something related to mathematics or computer science, you're basically open to do whatever you want, right? So you don't have to necessarily stay within one application area. You could also, I had many students that also went to finance, to consulting, to data engineering, etc. But I really wanted to stay in that, and this is also how I searched for potential institutions to go. And then I found the German Cancer Research Center, especially the Department of Intelligent Medical Systems, or at that point, it was called Computer Assisted Medical Interventions. So I think my application was a bit of unusual, because I remember when I wrote my motivation letter, I wrote something like, I am interested in a position as either a scientist or a PhD student. Because at that point, I didn't know what I should do. I thought I would generally be interested in pursuing a PhD, but I wasn't sure if I need that. I wasn't sure if I would stay in academics. I wasn't sure if I like academics in the first place. So I just thought, okay, let's take whatever they have. And I think that was actually also the reason why they took me, because they have a lot of interested PhD students, but they don't have a lot of scientists who do some, let's say, not so much research work, but perhaps also a little bit of other work, like implementation related tasks. So in the end, I started as a scientist, not as a PhD student. And when I started, there was a small introductory project where my supervisor told me if I could have a quick look into so-called challenges, so benchmarking competitions, which also was the first big thing that I started to working on. And these competitions are basically a method to compare AI methods, to find out which algorithm is the best for a specific research question, enables fair comparison on the same data, and winners often being the new state of the art. And as a small spoiler, I'm still working on these topics 9 years later. So it's not a small side project, but it turned out to be a really important project. And this is also my first, perhaps advice. You never know what happens, and sometimes chances come up, and then you should take it. So this was a project that where not many people worked on in that time. So I think it was really beneficial to jump on that at that stage. So some insights in the project, what we wanted to find out, we wanted to have a look at the quality of these competitions, because they have a very high impact. But what we found during the research is that there were a lot of problems related to quality control. So there was a huge discrepancy between the impact and the missing quality. And we wanted to know if the winners of these challenges are really the best methods as they claim to be. And when I had my first conference paper, I got very mixed opinions in the reviews. So there were people that gave me a strong accept, but I also got strong rejects. So quite mixed opinions. I ended up getting an oral presentation for this, and still I remember when I was at the poster, there were, let's say, lively discussions because we criticized the state of the art. And some people, especially younger people, thought, okay, that's a nice path to discuss. And while the, let's say, more established professors, perhaps some of them were not so happy with us criticizing what they have done. But still, as I said, it put us in somehow a distinct position, because we worked on something a little bit different than the others. And this also then brought me at some point to the decision, perhaps I should still be doing a PhD, because I was feeling that a bit different from the other scientists in the department. I was somehow doing the same kind of work as the PhD student. So I was writing papers, I published, I did specific research. I also did some implementation tasks. I worked on tools, I worked on software. But yeah, I had the feeling that the work that we have done was actually more impactful than I thought in the beginning. So therefore I thought, okay, why not? So I talked to my supervisor, and she also agreed that it makes sense. So I shifted a little bit, and I put my work all related to benchmarking and validation of AI methods. And this road is a good example of what I mean with that. Because what we, or where we go, depends on what we measure, as I say here. We often have a specific research question, a goal that we want to solve. So a specific, in my case, often a clinical question, for which we need an adequate way of measuring it. For example, by having a good metric, a good data set, etc. But what we're doing in practice, we're often optimizing for proxies. We're using some kind of data, we're using some kind of metrics. And this is often diverging from the real question that we have. And my research is all around these things. So as you see, I'm not working that much on let's say, traditional, what we think traditionally of data science. I'm not that much into working on a specific algorithm for a specific problem. Although I'm helping people with that, my specific work is more on the meta level, where I'm looking at problems of these approaches. And this is also what I've done in my thesis. So as you see here, I have a lot related to revealing flaws in common practice. So I'm criticizing a lot how we do specific things. So all the things in red are different parts of the research chain of validation related questions related to metrics, rankings, reporting to data, but also suggesting solutions on how to improve that. And I will explain a few details and examples in a bit. But let's keep on the timeline for now. So I worked on these meta topics, and at some point I finished my PhD in 2023. And it was, as I said, the topic was a bit different. So I think that's also the reason why I won a couple of prizes for it. So I think I would definitely encourage you, if you have a topic that is not that, let's say, mainstream, follow your gut feeling and pursue it. As I said, I started with a project that was not really interesting, and many people were not happy that we were doing it that way. But in the end, I just continued, and it turned out to be, an interesting topic. And nowadays, everyone is talking about benchmarking. So I think it was good that we jumped on that train before the hype started. Yeah, so after finishing the PhD, there's often another decision. What should you do? Many people from our division, for example, went to industry or went to different labs, but I liked what I had. So I also decided to stay as a postdoc in the division. And here I brought you a little diagram of our research division, which is grouped into specific subgroups. So we have the general division, and we have different so the division is grouped into different, let's say, topics. So we have things related to spectral imaging, we have things related to surgery and endoscopy, and we have the group called validation of intelligent systems, where I'm leading this subgroup, where we have I don't know how many people we have, I think 5 right now. I actually started leading this group in around 2017. But it really started to be useful during COVID, when we found that integrating another level of hierarchy for the division really helped. Because on the one hand, we were growing. It was quite difficult to talk to people during the pandemic. And given that we have had these group leads for the specific topics, for the students, they had someone else to talk to. It was not just our department lead who was super busy with supervising all of them, but it was really handy for them to talk to specific people. And I'm still very happy to be in this position to lead this small subgroup. And it also gave me somehow a nice and special situation. So I'm a postdoc. I'm still leading my own group within my larger group, but I don't have the, let's say, struggles of managing my own research group. So I don't have to deal that much on, let's say, financing and all these things. Although I still do grant work, but this gives me the opportunity to still pursue my own research, which is a really nice position for me. And I'm also now, since 2023, one of the deputy heads of the division. So I'm allowed to sign contracts. I'm involved in department relevant decisions. So I'm really into this department. And as you see, I stayed here for a long time, and I really like how my research has evolved also into my own interests. During that time, also, we were involved in Helmholtz Imaging, and perhaps you've heard about it. They also have a booth today, so if you're interested, check that out. And Helmholtz Imaging is one of the incubator units, and this is not specifically about medical imaging, but about imaging in general. And I think it's a very nice thing, also Helmholtz-wise, because this unit tackles the whole story for imaging, from data acquisition over image formation, data integration, etc., to the end of image analysis and validation. And here you also see how my research comes into place. I'm working in this last pillar of validation and dissemination. And we really work together, and not only on medical data sets, but also on other data sets, which is really great to get some insights and to have this interdisciplinary view that Helmholtz offers. So we're on the one hand, the domain scientists. In our specific case, it's a lot about clinicians, but also for other fields like biology and other sciences. And we have the AI scientists, and we work together to solve the problems, which is really, I think, a great position. And if you don't know Helmholtz Imaging, I think also nice about this unit is that we have research units at DKFZ, DZ, and DKFZ and MDC in Berlin. And we also have support units. So while I'm in the research unit, I'm doing research. Specifically, the support units take care of solving your problems and helping in your project. So if you have anything related to imaging, feel free to check out and get some help on getting started, on setting up the data, on which algorithms to use, etc. So I think this is really helpful, and I'm very happy to collaborate with these guys. Yeah, so now we're basically at the current stage, so to today. And I was asked also to talk a bit about a typical day in my life, which is very difficult to answer because every day is different. But I wanted to bring you a few building blocks of what I do or what could make up my day, which could be very different things. So on the one hand, it's supervision. I told you I'm deputy head. I'm having my own subgroup in the department, so I do a lot of supervision, feedback on different things. On the one hand, personal things, but also things related to the research on papers, etc. Which also brings me to the next one. Writing takes up a lot of time. On the one hand, papers, either my own or from my students. Working on grants, emails, of course, is a large part as well. I'm doing my own research, which I'm very happy that I have the time to do so. And I will talk about a few topics or a few research topics in a bit. Design is something that came a bit unexpected, honestly. So I'm at some point we had a designer in the division, but she left a few years ago. And then we suddenly saw that it's good to have someone who has really who's good in doing figures and doing designs and doing presentations, etc. So at some point, my supervisor figured out that I made nice presentations, and this is how I somehow ended up in taking over that design role. I'm definitely not a professional, but I took a few courses, and I'm getting better and better, and also definitely helps, for research. Yeah, and a big part of my work is meetings and collaborative work. So I am part of a lot of international groups, consortia, initiatives. And I'm very grateful for that. And that is really something that motivates me. And I talk to a lot of people. And this is also where I wanted to motivate my one of the larger projects that I've worked on in the past years, where I worked with a very big international consortium on the so-called metrics reloaded project, where we wanted to establish problem-specific performance metric recommendations for imaging. And as you see here, this was a very big author list. So very, very many institutions involved in this project from very, very different expertises. Many Helmholtz researchers involved here. So we've worked with AI research, with clinicians, with biologists, statisticians, clinical epidemiologists. So the list is very long, and it was really a great experience to talk to all these different people and exchange ideas and feedback. And so this project comes from the problem that we're often using performance metrics for our algorithms that are not really suitable for the task at hand. So here I brought an example of a brain tumor segmentation. So you see here the reference on the left-hand side, the prediction on the right-hand side, and the blue thing that you see is a brain tumor. And if you compare these two images, they look pretty similar. And also this algorithm here is a state-of-the-art algorithm for a state-of-the-art data set. And the standard metric, this DSC, will tell us 94% performance, which is a great score. However, this metric is not really reflecting what we want, because from a clinical perspective, we're very much interested in small lesions of a patient, not that much into these big tumors. And if we look at a different slice of a different patient, we will see that there's, that we are missing these tiny lesions in the brain. And this metric is quite misleading. We would be needing something like percentage of missed lesions. So without going into further detail, this project, we used a methodology which allowed us to generalize across domains, which is also one of the main things that we advertise at Helmholtz Imaging. So it's independent of what kind of image you use. We will give you recommendations. And we do so by extracting from the problem rather than problem properties, by which we can then state which metrics are appropriate and which ones are not. And one of the interesting things also about this project is also related to the support unit of Helmholtz Imaging. We have also made this whole research into an online toolkit. So we made sure that it's very user friendly, that it can be used very easily by the community, independent of whether it's medical research or not. But you would see the recommendations for specific problems popping up on the site by just answering a few questions. So coming to the end, I have a few more things that I wanted to mention. Also something that we're very much interested in, especially I like to focus on these things, are educational efforts. And for example, we have participated in an educational challenge for a few times, and always were among the top submissions. We also do webinars, so I'm putting a lot of focus into teaching and making sure that the community shifts a little bit from the current research practices to the things how they should be done. Because I think one of the big problems from my experience is that we learn more about models than we learn about validation. So yeah, my work summarized is questioning the state of the art to identify hidden risks in medical image analysis. So you see a few of the papers that I was involved in. It was always a bit about, are we doing it right, and how can we make it better, and what are the problems and risks that can arise from that? Yeah, and I hope that you got some inspiration here.